Hi, in this video, we're going to talk about the idea of functional method as data. Now, this could be a little unconventional for people who are more used to languages like C++ or Java, and therefore the cartoons. Now, we've mentioned multiple times that in Python, everything is an object. And this object, it's not the base class for all classes. It means an instance of some type, right? And so with everything being an object, that means all of them would have a type, and they will all have an ID, among other things. So, and this is the picture we've been seeing, been talking about, that a name is really just a reference to an actual object, right? So when we assign 10 to A, the name is a reference to an int object that holds the value 10. And if we instantiate a car instance and assign to car1, then car1 is just a reference to a car object. So that's what we've been talking about. Now, we've also been saying that if we do an assignment, then it's really just creating another name, and that and the new variable, like B in this case, or car2 in this case, is just another reference to the same object that the value on the right-hand side of the assignment operator was referencing, right? So this is the picture, and if we print out the ID of, say, A and B, they are exactly the same ID, and the same applies to car 2 and car 1. Now, as it turns out, this idea not only applies to built-in types like integer 10 or user-defined type like car, it actually applies to functions as well. And so we're going to see how it applies to built-in function first. So functions such as print is actually represented by an object. Okay, and the name print then is really just a reference to the function, to the object that represents the print function, which means we, among other things, we can print out the type and ID of the function print, which I wrote up here. And well, I guess I already run it. I can run it again. But anyway, so the type for print is that it's a built-in function or method. It's not a huge difference between function and method. So, and also ID for print is this wonderful hex number. Okay, so in that regard, it's really kind of the same as an int, or as a user-defined, an instance of a user-defined type. One thing I want to point out here is we usually, when we see a function, we usually call a function, right? And that is with parentheses after the name of the function. Here we are referring to the function itself. We are not calling the function, and therefore you see the word print without the parentheses. All right, so what this means is that we can actually give this function object a different name by assigning it the current name to a new name. So for example, I already typed it out here. I'm assigning the function print to the name P. If, I don't know, I feel like I don't want to print, I don't want to type 5 characters, I want to just type 1 character, right? Now, in that case, this P, as you can see in this picture, I mean, P is referencing the same function object as the name print. So if we print out its type and its ID, we would expect both of them to be exactly the same as the original print. So yeah, the class is the same, and the ID is also exactly the same. And here again, I want to point out that this print is not followed by a pair of parentheses, because we are assigning the function itself to a different name. We're not assigning the result of calling the function to a different name. What that further implies is now we can use the name P to call the function print by doing, I can just say P hello world, and it should do exactly the same thing as print hello world would do, and indeed it does. So now I would like you to try the same thing, but with user-defined functions. So um, what I like you to do is just define a function, say greeting, and all it does is it prints hello world, and then you can assign the function you just wrote to a different name, say hello, and then you can print out the type and the ID of both of these functions, greeting and hello, and then finally run both of them and see if they do exactly the same thing. All right, so please pause the video and give that a try. And assuming you've done that, here is what I did. Just define a greeting, print hello world, assign greeting to hello, print out the type and ID, and then just run them, right? So when we run it, as you would expect, the greeting and hello, they are both type function. So it's not a built-in functional method anymore. It's just a function, a user-defined function, I guess. And then they have exactly the same ID. And when we run them by either name, they print out the exact same messages. So how is something like this useful? Well, it's useful in many different ways, and I'll show you one example. So in this example, we're writing a function called testString, and it kind of just tests the various property of a given string, like is it a digit, is it alphabets, etc., etc. Right? And one way we can do it is obviously we can just call string is a digit on the given string S, is it alpha, is it space, and so on and so forth. We can write it like that. It works. But what are some of the problems with this particular approach? Well, one thing is, we're copying a lot of code and paste it and do a little modification. So, copy and paste code is generally not a good idea if we can avoid it. And then when we do the modification after we copy it, we have to do the modification in two places, right? It's the function name appears in the string as well as the actual function call. So it's not nice that we have to do it in two places. So how can we kind of fix both of these problems? Well, by using the idea we just talked about, but to get there, let me show you two intermediate steps first. So one of the things is we can say assign one of the string is whatever method to a different name, right? So I assign to foo, and then I can just use foo exactly the same as is digit, right? So ABC is not digit, and then 1, 2, 3 is. So that, right? Now, not only we can assign the method to a different name, we can actually even put it in something like a list. Okay, so here I create a bar, which is a list that consists of one function method, string.isDigit. And now to get to is.digit is the first element in the list of bar. So bar index element at 0, and that is string isDigit. And I can call it on ABC, and that should give me false, it's not a digit. Or I can say 1, 2, 3, and that is a digit. Now we can take advantage of the fact that we can put methods in a list to do the following. So we're going to create a list of the tests, which consists of string is digit, is alpha, and is space. The three things that we test a string for. And then we can loop through this list of tests. Right? And so for each of the tests in this list, so a test would take on, the string is digit first, and then string is alpha, and so on. Now, what do we want to do inside the body of the loop? Well, we just want to do this, right? And there's three things that we're printing in this print statement. The first thing is the string itself. And then the second thing is the name of the function. And the third thing is the result of calling the function, the function or the method. And we can do exactly that in the body. So we'll print out three things. The first thing is just the string we're testing. Second thing is the name of the function, the test function. So we can get a done the name attribute of that particular method. And then finally, we will just invoke or call the test method, which is one of these, on the string. Okay, so we can run it, or we'll run both of these versions, and they yield identical result for the string ABC. And now to show you the advantage of this approach, despite the fact that this one line looks slightly more complicated, I'm going to ask you to add an additional test to both versions of this test string function. And so this is the original version, and I'm going to ask you to add that one additional test is upper. Is the given S, is that all uppercase? So please pause the video and give that a try. And assuming you've done that, and this is what you would do, right? In this version, just copy this line of code, change the function call, and that's it. Not too hard, but let's try to do the same thing for our new version that use a list of methods. So pause the video, give this a try. So for this version, I hope you did something as simple as this, right? Just add that is upper method to a list of tests, and then that test will be applied on the given S. So I hope that between these two versions, the new version using a list of tests is a lot simpler to maintain, to add additional tests, and so I hope you see its advantages.